Good afternoon, everyone. Welcome you all. The screen is visible?
Yes.
Yes, sir.
Okay. Okay. So in the previous lecture, we have completed the unit number 4. Sorry, unit number 5, we have completed network functions. Now today we are going to start the next unit, that is the unit number 6. The name of unit is filters and attenuators. So according to our triple P pattern, we can discuss some points related to filters and network chapter, filters and attenuator chapter. And then we can start from the introduction of the filter. And if possible, we can cover the classification of the filters up to today. So we can start according to the triple P point. That is what will be the, what are the contents in this chapter we are learning. Then the meaning of title, then importance of this chapter, why we are learning, then at the end of this chapter what we are getting, that will be the outcome. Then we can discuss related to applications of filters and attenuators, then object outcome we can discuss, and later on which book we have to refer for this particular chapter. And then we can move towards the first point of this chapter, that is the introduction of filters. In that we can cover the definition, we can cover the applications of filters, then we can cover the different types of the filters, and after that we can discuss one by one point in detail in this chapter. So first point will be the syllabus. So what are the contents here? And this is the important subject, important chapter with respect to the exam point of view, as well as in this chapter we are designing something. So what we are designing? We are designing the constant K-type filter. We are designing the modified, that is M-derived filters. Then we are designing the different types of attenuators also. So up to now, up to the fifth chapter, what we can say, we are applying some rules, applying some technical techniques, applying some theorems to find out the responses, to find out the circuit parameters. But in this chapter, we are designing the circuit, we are designing the attenuators and filters, which are the type of passive, we can say, because there are the active filters and passive filters. So active filters are in digital signal processing, in image processing, in signal systems we can design. But passive filters, which are made by different passive elements like resistor, inductor, capacitors. So those we are designing in this chapter here. So first, the name of unit, that is filters and attenuators. So we are learning only passive filters here. That is, I am telling, because in filters there are the two types, active as well as passive. But for our syllabus only, there are the passive filters. So syllabus, we can discuss. First of all, there are the two parts. One is, we can call it as filters, and second part is attenuators. So in filters, we are going to discuss from the introduction part. So introduction, I will write introduction. It will cover the definition, application, all those things. Then classification, and characteristics. Characteristics are very important. So characteristics we can generally call, we can draw with respect to two different parameters. One characteristics is with respect to frequency and voltage gain. Oh, and second characteristics which we are using in this chapter, that is with respect to we can say that the frequency, and on y-axis we are taking the attenuation parameter. Okay, so attenuation from 0% to 100%, that we are taking. So with respect to that, we are discussing the characteristics of the filters. So classification, in that we are understanding classification and characteristics of low pass filter, then high pass filter, then after that band pass filter, and lastly band stop filters. So band stop filter is also having another name, that is a band elimination. Okay, so first point will be the introduction, classification and characteristics of different filter, that is low pass filter, high pass filter, band pass filter and band stop filters. After that we are going to design and understand the constant K type. Why it is called as K type? K means some constant value. So constant K type filters we are going to design. We are going to understand the design formulas, the design factors. So constant K type filters, in that constant K type low pass filter LPF, then constant K type high pass filter, that is HPF, then constant K type band pass filter BPF, and then last one constant K type band stop filter, it is also known as band elimination filter, that is BEF. Okay, so after that, if there are some modification to get the attenuation characteristics ideally. Okay, so for that we have to make some modifications in the circuit diagram, and after modification the constant K type filters are converted into M derived filters. So M derived filters we are going to learn M derived filters. So with respect to only LPF and high pass filter we are discussing the M derived filter, and HPF and high pass filter, low pass filter and high pass filter with respect to M derived filters. So these are the part or content of the filter part. After that, attenuators will start. Attenuators. So some introduction part will cover, and after that, relationship between Napier and decibel. So there are the two different units by which we can measure the attenuation. One is the Napier and another is the decibel. So relationship between Napier and decibel we have to understand. Then after that, design of T type, pi type and lattice type attenuators. That are the contents in the attenuator parts. So these are the contents of our syllabus of this particular unit number 6, filters and attenuators. Okay, so after that we can discuss now the title of the chapter. So what is the title of the chapter? That is the filters and attenuators. We can easily understand, but the definition and working function of filters and attenuators we need to understand. So anyone knows what is the function of attenuator and what is the function of filter, for which purpose they are using? Anyone? So first we can talk about filters. What is the task of filters? Why we are using in the communication system, in the electronic system? Where are the applications of these filters? Anyone?
They use at receiver side if any noise is added in signal.
Okay, so for removing unwanted signal. Very good. Next, any function, any task? Anyone knows what is the function of low pass filter?
It passes the low frequency only.
Yes, very good. So similarly, high pass filter, it will passes the high frequency. So which factor will decides how much frequency it should pass and how much frequency signal it should attenuate? So that frequency is named as what? Cutoff frequency. Barabar hai? So cutoff frequency will be there. So that can decide which signals has to pass, which signal has to attenuate. Barabar hai ki nahi? So for low pass filter, for high pass filter, there is only one cutoff frequency, FC. But for band pass filter or band stop filters, there are the two cutoff frequencies. One is F1, that is called as lower cutoff frequency, and another is called as F2, that is the upper cutoff frequency. Okay, so these two cutoff frequencies will decide the different bands or different sections. So filters, we can say it is a device or circuit, we can say, which freely passes the desired band, of frequencies, while suppressing all other band of frequencies. Why I'm talking with respect to band? Because it is applicable for band pass as well as band stop. So it is device or circuit, we can say, which freely passes the desired band of frequency while suppressing, rejecting, removing all other band of frequencies. Okay, so there are the many examples which already we have mentioned in the syllabus. That is low pass filter, high pass filter, band stop, and band pass. Next, where are the applications of those filters and why we are using? So filters are used in signal processing, image processing. Image is nothing but in the form of signal. Image processing. Okay. Next, in the network, etc. So next, similarly, we can try to understand the attenuators. What is attenuator? What is the function of attenuator? Attenuator म्हणजे काय किंवा attenuation म्हणजे काय? Yes, anyone knows?
It reduces power of signal.
Yes, power we cannot say, but amplitude. Okay.
Yes.
So power attenuator different. Particularly, we cannot say that only it will reduce the power, but it reduces the strength of signal. Strength means what? It should reduce the amplitude of the signal. Okay, up to 0% it can reduce. So attenuator means what? It is a device. Or we can say the circuit which we are using in laboratory also, which reduces the strength of signal. Reduces the strength, that is, we can consider amplitude of signal. Okay, so attenuators we are using in the laboratory in function generator. Anyone observed in function generator? Many of you used, especially diploma students. Those who have completed diploma, anyone observed in the function generator the attenuation is there? Anyone? Those who have completed diploma, 15 students are there in our class. Anyone observed? There is 40 dB, 60 dB attenuation will be there, attenuation of the signal. By pressing that, you can get the attenuation. Okay, so in function generator they are used attenuator. Especially attenuator devices are there in the market. So in the communication system we can use attenuation. Whenever needed we can use the attenuation. Okay, so this is the meaning of filters and attenuators. That is the title of the chapter. So any questions you have? कुणाला काही questions असतील तर विचारू शकता. So we can move towards the next point. That is the central idea of the chapter. We can finish these all points as early as possible so that we can move towards the introduction part. Okay. So next point will be the central idea of the chapter. Central idea of the chapter. So we can consider this chapter is divided into two parts. Okay. So one is we can consider as a filters that already we have seen in the syllabus, and second one is attenuators. Okay. Now one by one, in the constant K type, filters are divided into two part, constant K type, and second one is M derived section filters or M derived filters. So in the attenuators, we are going to design three different types of attenuators. So first attenuator will be T type. Second one is pi type. Third one is lattice. Okay. So why we have chosen the chapter number 5 and 6 immediately after chapter number 3? Anyone can tell? Chapter number 3 झालं, chapter number 5th का सुरू केलं आपण? And after 5th, why we have taken chapter 6? Anyone?
Maybe because of two-port network.
Yes, very good. So chapter number 3 is two-port network. So in the chapter number 5 also we have seen the use of two-port network. So based on two-port network only, we are finding out different driving point function, different transfer functions. Okay. So after that, immediately this chapter we have started, that is chapter number 6, because in that whatever the filters and attenuators, especially filters, those are of T type and pi type. All filters are made up of two sections. One is T section, another is the pi section. So T type and pi types we are going to use for designing filters as well as attenuators. So T type and pi type we already learned in the chapter number 3, that is the two-port network. Okay, so for that purpose we have selected the chapter number 5 and then chapter number 6, and then at the last we are learning the chapter number 4. Okay, so in the constant K type, we are learning constant K type low pass filter, then constant K type high pass filter. After that, constant K type band pass filter, and then band stop filter. So in the M derived, only we are discussing two M derived filters, that is the M derived low pass filter and M derived high pass filter. So this is what central idea of the chapter, what we are learning, what we are discussing in this particular chapter here. Now next we can discuss with importance of the chapter. Why we are learning, what are the use of designing the filters and attenuators in the electronic product design or in the electronic circuit analysis or in the design of different communication system. What is the use of these filters and attenuators? So already we discussed the applications. At the end, what we are getting? Suppose chapter I have finished. What you are getting? That is nothing but outcome. So outcome is what? Outcome is through applications. Outcome म्हणजे काय? की जे काही तुम्ही शिकलात त्याचा वापर कुठेतरी व्हायला पाहिजे in the industries for the giving the solutions for different societal applications, societal problems. Okay. So filters are mainly used in the design of communication system. So everyone are using smart mobiles. So any filters are present in your mobile? Yes or no? Whether filters are present in your smart mobile or not, that is my question.
Yes, sir.
So what is the role of those filters then?
Working smooth.
Okay. So in communication system, you may learn in the third year. Okay. So in third year, mobile communication subject is there, advanced mobile communication system. So each mobile will act as a receiver as well as transmitter. So when you are making a voice call or any data, so it is working with the help of signal. But the 4G, 5G, whatever the technology you are using for mobile communication, that works on OFDM. OFDM means what? Orthogonal frequency division multiplexing. Okay, so that technique, in that technique, it works on frequency as well as time. So you cannot understand at this level because you not learned still the frequency division multiplexing, time division multiplexing, whether you completed in the analog communication.
No, sir.
Okay. So whenever the communication next point will be there, you can understand that frequency division multiplexing, then time division multiplexing, code division multiplexing, then OFDM orthogonal. So in that, the x-axis is based on time and y-axis is based on frequency. So given signal, whatever you are getting transmitting and receiving, in the mobile communication, those are based on frequency signal. So different frequency channels are there, different channels are there. So for whenever the frequency term will come, the filters will exist. Right? So what is the role of that filters? It will takes only the required frequency signal, while it will eliminates the remaining frequency bands. So filters plays very important role in the mobile communication or in the entire communication system. The filter have applications. Okay, so for that purpose we need to understand, we need to discuss the filters. Okay, even though these are the passive filters, don't worry, but passive filters are also required in the most of the applications. So these are the first important application. Filters are mainly used in the design of communication systems. Second one is filters are used to transmit desired band of frequencies. Filters are used to transmit desired band of frequencies. Desired band of frequencies. So in the signal processing, in the image processing, you can use it. So next, attenuators, where we can use. So attenuators also used in communication systems. So used in communication system. In the laboratory, example we can give in the laboratory for testing the signal, for testing the different project signal, different circuit you can use. For testing the circuit, we can consider, we can design the attenuator. So these are the some applications, and through application we can understand the importance of this particular chapter here. Okay, so we are moving towards the last points. Last point, that is the which book we have to refer and what will be the CO. CO means what? Course outcome. So this particular chapter having particular CO, so that we can consider as a CO number 6. So CO number 6 is written like this: ET 213.6. So what will be the statement of this particular CO? That will be the design of प्रत्येकांना प्रत्येक सीओ माहित पाहिजे प्रत्येक चॅप्टरचे. ओके, ऍटलीस्ट इन दॅट प्रेझेंट सेमिस्टर. Design of passive filters and attenuators. Design of passive filters and attenuators. Simple. It is very simple. Based on the chapter name only you can remember. Design of passive filters and attenuators. That is the CO number 6. Okay. And the recommended book, as usual. Anyone tell what is the name of that book? Textbook? Yes, textbook. I told number of times. Circuit and networks. Circuit and networks by A. Sudhakar. A. Sudhakar and S. Shamonpalli. Okay, that is of Tata McGraw-Hill publication. Tata McGraw-Hill publication. So these are the, according to triple P, we have covered all the points before starting the actual content of this syllabus. Now if any questions will be based on that, you can ask. Otherwise we can start our chapter. कोणाला काही क्वेश्चन्स असतील तर विचारू शकता. Yes, anyone? Okay, so we can start now. The first point, introduction. Unit number 6, filters and attenuators. Filters and attenuators. So introduction part. So what do you mean by filters? Already we have seen. Once again we can write the definition. What do you mean by filter? Anyone remember? Already I told. It is a reactive network. Reactive, why I am using the word? Because we are using inductor and capacitor. So it is having reactive impedances. So it is a reactive network which freely passes the desired band of frequency, which freely passes the desired band of frequencies while suppressing or rejecting all other frequency bands, or all other band of frequency, we can say all other band of frequencies. So this is what the definition already we have discussed here. So why I have used the word reactive? So that I will write here. These filters are constructed. These filters are constructed by using purely reactive elements. purely reactive elements. Purely reactive elements. That is L and C. L and C are called as what? Purely reactive elements, because those reactances depends on what? Frequency. XL म्हणजे काय? Remember the second chapter, resonance. What is XL? XL and XC चा formula काय? Please reply fast. What is the formula of XL?
XL equal to 2 pi FL. And
Yes.
X
So it
equal to
depends on frequency, no?
yes.
So if whenever the any term depends on frequency, that is required here. So when whether resistor value depends on frequency, resistor R depends on frequency. Yes or no? Resistor value does not depends on frequency. It is frequency independent. Whereas the reactive impedances of inductor and capacitor, that is XL and XC, depends on what? Frequency. Okay. So these filters are constructed by purely reactive elements, that is L and C. Because why we are using L and C only? Because to get zero attenuation, that is completely zero attenuation in stop band, completely attenuation or zero attenuation in stop band, sorry, in pass band zero attenuation, and 100% attenuation in stop band. Because to get zero attenuation in pass band and 100% attenuation in stop band. So there are the two bands, one is pass band and another is stop band. So zero attenuation must be there in the pass band. जे frequency तुम्हाला pass करायचे तिथं काहीही attenuation होता कामा नये. The signal as it is, it should pass. Whereas in the attenuation band or in the stop band, the signal must be ideally 100% attenuated. 100% attenuation होत नसतो, but ideally it should be 100%. Okay. So this is the important point why we are using the reactive elements like inductor and capacitor for the design of passive filters. Okay. So next point is what? What is the pass band and what is the stop band? So definition of pass band. Pass band is also named as another name transmission band. जिथून सिग्नल पास केलं जातं. Transmission band oblique pass band. So anyone can tell the definition now? Anyone? You can use about 2 sentences for understanding this pass band or transmission band. Anyone? Okay. The filter which produces zero attenuation, the filter which produces zero attenuation in the desired band of frequency, in the desired band of frequency, the filter which produces zero attenuation in the desired band of frequencies is called as pass band or transmission band. म्हणजे ज्या बँड मध्ये 0 अटेन्युएशन होऊन तो सिग्नल पास केला जातो तो बँड म्हणजेच काय पास बँड और ट्रान्समिशन बँड. नेक्स्ट स्टॉप बँड और attenuation band. Stop band is also known as attenuation band. What is definition? Exactly opposite. The band in which the filter attenuates 100% signal, 100% signal frequencies is called as stop band. ज्या बँड मध्ये 100% signal attenuate होतो, the signal which does not get passed, that band is called as what? Stop band oblique attenuation band. Stop band or attenuation band. So once you understand what do you mean by stop band and pass band, then it is easy to understand the characteristics of all filters. Okay. Now next one, what do you mean by cutoff frequency? What do you mean by cutoff frequency? So for low pass filter, high pass filter, we are using FC, and for band pass filter and band stop filter, there are the two cutoff frequency. One is lower and another is upper. That is the F1 and F2. So what is that? What is the definition of that cutoff frequency? What is the role of, or what is the function of that cutoff frequency? It is the frequency. Yes.
A frequency at which frequency start to pass.
Okay. So as we already discussed the pass band and stop band. मग पास बँड कुठपर्यंत आहे आणि स्टॉप बँड कुठपर्यंत आहे किंवा पास बँड आणि स्टॉप बँड सेपरेट कोण करणार आहे? Who will decide where the pass band will start, where the pass band will end, where the stop band start, stop band end? So that will be decided by what? Frequency, particular frequency. So that frequency is called as what? Cutoff frequency. Okay. So definition will be like this: the frequency which separates the pass band, it separates the pass band and stop band, is defined as cutoff frequency. Is defined as cutoff frequency of filter. So for low pass filter and high pass filter, only one cutoff frequency is there, that is named as FC. But for band pass and band stop, there are the two different cutoff frequencies will be there, lower and upper. Okay. So this is the definition of cutoff frequency. So where are the applications of filter? General application where we can use. Number one, communication system. Communication system. It may be mobile, it may be radio, it may be television, any communication system. Second one, any general applications?
Image processing.
Yes, image oblique signal processing. So communication will cover actually everything, because signal and image all are the parts of the communication system. Okay. So general application will be the communication system here. In that we can write particular television broadcasting, television system, radio system. Then we can use it in the mobile communication. Okay. So all special applications, special uses, you can mention it under the communication system. So this is what the introduction part of the filter. If any questions will be there, you can ask. Now we are going to discuss the classification and characteristics of the filter. Still we have 15 minutes. We have to cover the classification and characteristics of the filter. Okay. So combinedly we can take classification, and characteristics of filters. Classification and characteristics of the filters. Now, general classification we can take. With respect to filters, we can take. So how many filters we are going to discuss in this chapter? Forget about constant K type, M derived. How many are there and which are those? Yes, fast.
4.
Tell one by one.
Low pass, high pass, band pass.
Yes, low pass, that is LPF. Next, high pass, that is HPF. Next, band pass,
Stop.
that is the BPF. And next, band stop oblique elimination, in bracket BSF oblique BEF. So these are the 4 filters that we are going to discuss with the help of characteristics, ideal as well as practical. And after that, we are going to start filter networks, and then we are moving towards the constant K type filters. Okay, so up to constant K type filter, there is the theoretical part, purely theoretical part. So, and then after that, we are going to start the design part. Okay, so up to the theoretical part, it looks like what we can say, there are the different derivations, different equations, different conceptual point, different diagram, different the graph we can say related to the characteristics. So all the theory part we have to cover before starting the constant K type filters for the design. Now next, characteristics we can start one by one. So first we can take the low pass filter. Low pass filter. So anyone can tell what is mean by low pass filter, or what is the function of low pass filter? What is the definition? Anyone can tell?
The filter which passes the low frequency only, which is desired as the filter.
Yes, low frequency up to what? Which factor will decide up to which frequency it has to send without attenuation?
Frequency.
Yes, yes. So cutoff frequency, don't forget to mention in the definition. Okay, so you can see it is a filter. First of all, we can discuss the definition or task of this particular device. It is a filter which passes all frequencies, up to cutoff frequency, FC, without attenuation किंवा 0% म्हणू आपण, without attenuation, and attenuates and attenuates all frequencies that is 100% attenuation, all frequencies above cutoff frequency FC. Now you understood? It is a filter which passes all frequencies up to cutoff frequency FC. जिथून सुरुवात होते 0, minimum, whatever there, up to cutoff frequency, whatever the signals are there, that all gets passes without attenuation. Means as it is, signal gets passed. But the remaining, that is after cutoff frequency, whatever the signals are there, whatever the frequency signals are there, that those all are gets under 100% attenuated. Means it cannot pass. Okay, so cutoff frequency will decide how much frequency signals has to pass and how much signal has to attenuate completely. Are you getting my point? So the attenuation characteristics. So already you learned different types of characteristics in the ECAT subject or anything. मग ते काय असेल बघा, तुम्ही असे characteristics तुम्ही शिकला असेल ECAT मध्ये वगैरे. So this is not with respect to our attenuation characteristics. So on x-axis frequency will be there. Okay, on y-axis we are taking what? Gain, voltage gain mana, signal gain mana. So gain in dB. So signal will be like this. So here somewhat FC cutoff frequency will be there like this. Okay, किंवा आपण FC इथं move होऊ शकतो. FC somewhere consider here, somewhere consider here. Up to which frequency it is giving constant gain, and after that the gain is reducing. So this factor will decide the cutoff frequency. So this is what general characteristics of low pass filter. But we are discussing what? Attenuation characteristics. Attenuation characteristics we are discussing. So that is I will draw now. So general characteristics in that frequency versus voltage gain is there, but in the attenuation characteristics we are discussing the frequency versus attenuation, because we are saying that no, in pass band the attenuation is 0% and in stop band the attenuation is 100%. So with respect to attenuation we are going to draw the and understand the characteristics. So here on x-axis there is a frequency in hertz, and on y-axis there is attenuation. So attenuation is denoted as alpha. Attenuation may be represented with the help of unit Napier or decibel. Attenuation तुम्ही decibel मध्ये घेऊ शकता किंवा Napier मध्ये घेऊ शकता. So I am taking here decibel. So for low pass filter, how it will be the characteristics? Suppose somewhere here it is FC, cutoff frequency, and on y-axis there is attenuation. Here it is 0% and here it is somewhere suppose 100%. So how you are drawing the characteristics now? Anyone? Yes, anyone? कसा असेल characteristics? Zero to FC, pass band है का stop band है?
Pass.
Yes. So in pass band, attenuation is 0% or 100%? That is my question.
0.
Yes. So in pass band, that is 0 to FC, there is attenuation 0%, means the total, the graph will be like this. म्हणजे इथं 0 attenuation है, attenuation होणारच नहीं है. Okay. But after cutoff frequency FC, there is total 100% attenuation. So that will be like this to infinite, because we are taking infinite here. So this is what? Stop band or pass band? 0 to FC.
Pass band.
Yes. So it is what? Pass band oblique transmission band. So this is what? Stop band oblique attenuation band. Okay. So pass band oblique transmission band is from 0 to FC, and stop band is from FC to infinite. FC to infinite. So this is what the ideal characteristics of low pass filter. याला काय म्हणतो आपण एकदम शार्प जर असं तुम्हाला जर कट ऑफ फ्रिक्वेन्सी मिळत असेल, if the sharp characteristics you are getting, then it is called as what? Ideal characteristics. Ideal characteristics of low pass filter. Actually graph कसा असतो? I will tell like this. The graph is like this. For attenuation characteristics. So this is attenuation. This is frequency F. So we cannot get a sharp one. So here we are getting the curve. So this is what FC. So this is what practical characteristics. Practical characteristics, attenuation characteristics of LPF. Practical attenuation characteristics of low pass filter. So this is what ideal characteristics of low pass filter. Now understood the difference between ideal characteristics of low pass filter and and practical characteristics of low pass filter with respect to attenuation. Yes or no, everyone?
Yes, sir.
Okay. So here, what is the range of pass band here? Pass band's range काय आहे इथं?
0 to FC.
Yes, very good. 0 to FC. And what is the range of stop band?
FC to infinity.
Yes, FC to or greater than FC म्हणू शकता. FC to infinite किंवा greater than FC. Equal to should come in the pass band. Okay. So greater than FC, you can say that. So time is over now. We can stop because actually I have to complete all the characteristics of remaining filters also. But we can discuss it in the next lecture. So any questions from your side? So first 2 to 3 lectures we have to invest for theoretical point, and then we can move towards the constant K type. Still 2 lectures we require minimum 1.5 lectures we require to complete the theoretical part of the filter point. So once we can complete theoretical, it is very interesting because all are based on simple formulas. At the end, I will tell one summary sheet. I will discuss it, how to remember. Total 18 formulas are there, minimum 18. 18 formulas we require. So how to remember that, I can tell the hint. So if any questions will be there, you can ask. Otherwise, we can stop for today. Okay. Thank you, everyone.